Okay, circular motion, this is where we're going to be hanging at an angle. So let's say that we are thinking of, let's challenge the chemistry class to a game of Tough Man Tetherball. So let's see, let's tie, in our Tough Man Tetherball, let's tie an anvil to a rope. There. So there's our anvil dangling down, spinning in a vertical circle. Let's say this is 30 degrees, and we'll say that the rope itself has a length of 3 meters. And what we're going to do is we're going to give the chemistry class the first serve, and we're going to figure out how fast the anvil is going to come towards us. Okay, so the circular speed of the anvil, that's what we're kind of looking for. We don't need to know the mass of the anvil because it's going to end up canceling out anyways. But if you want to know the mass of the anvil, how about we call the mass of the anvil 18 kilograms? Okay, just for having a mass's sake. Let's draw what we know. We know Fg is going to be pulling it straight down. We know that we're going to have on our rope a tension. We're knowing that we're going to have a tension in the y direction. We also know that we're going to have a tension in the x direction, tension in the x direction. And we know this tension in the x direction can slide down to here and be this way. But this is circular motion, so that's actually going to be Fc, towards the center. Okay, so let's see here. What are we going to do? Well, let's make some statements here about things that we know. We know that force due to gravity is going to be equal to tension in the y direction. And we also know that tension in the x direction is going to be equal to Fc, or circular motion, or centripetal force. So let's figure both of these things out. Fg is going to be mass times gravity. Tension in the y direction, well, if this is 30, this is 30, that's the adjacent side, so that's going to be T cosine 30 degrees. And this one is going to end up being mv squared over r is going to be equal to tx is opposite, so that's going to be t sine of 30. T sine of 30. Okay, so now what we want to do, I don't want to work with this stuff on this side, so I'm going to just flip everything around, and I'm also going to bring it over here. So let's go t cosine of 30 degrees equals mg, and t sine of 30 equals mv squared over r. Now, let's see, what am I going to do here? I'm going to solve this top one here. I'm going to solve it for t. So that's going to give me mg over cosine of, I was going to say theta, but cosine of 30. So solving this, bring that underneath, t equals mg over the cosine of 30. Now I'm going to take this, and I'm going to put it in for my t here. So that's going to end up being mg cosine of 30 times the sine of 30 equals mv squared over r. M's cancel. This is starting to look familiar, hey, like the very previous video. Sine over cosine, sine of 30 over cos of 30. I'm going to bring this g down here. That's v squared over rg. Come this way. That's tangent of theta v squared over rg. Now, this is what we had as our previous formula for banked curves, and that was the angle that you could have something going at a certain velocity that it wouldn't slide up or down. Well, this is now the angle that you would need to have something go around in a circle, or a hanging circle at an angle, I guess, or whatever you want to call this, tetherball, to have it spin around at a certain angle. What velocity to find the angle, or what angle to find the velocity. So we've been given the angle, we want to find the velocity. So this isn't the situation we want. We want ours to be in terms of v's, because we want to know what the chemistry class can serve at. So that means Rg tangent of theta is what they can serve at. So what did we say? We said radius Well, we don't know what the radius is. We do know what the length of the rope is. So I'm going to go here, and I want to know what this is. So that's going to be my x value. I know the hypotenuse. This is sine, so x is going to end up being 3 sine of 30, which ends up equaling 1.5 meters. So now I can go back down here, and I can go 1.5 times 10 times the tangent of 30 degrees. I plug all that in, and that'll give me my velocity. And they serve the anvil at a whopping 2.94 meters per second. With a serve like that, no wonder they're not going to beat us. So, there you go. Hanging at an angle, circular motion.